At this point, we have a basic skeleton of our chat application, but just displaying static data isn't terribly interesting. In this next section, we'll start making our application dynamic, and that means getting our hands dirty with the AWS Lambda service. Lambda is really the secret to how serverless applications work. We'll also use the Identity and Access Management Service, or IAM for short, to manage permissions between the AWS services we're going to use, and we'll use the API gateway in AWS to introduce a clean interface between our web browser clients and the backend services they need. We'll also introduce cross-origin resource sharing, or CORS for short, to grant access to the web clients to the services they need on the back end. And by the end of this section, we'll be retrieving chat conversations stored in S3 through the API gateway and Lambda, which gets us a lot closer to having a real application. There's a lot to cover here, so let's dive in and start talking about what AWS Lambda is all about. So if you think HTML and CSS and JavaScript seem like different languages, let's talk about a real language, Greek. We're going to talk about Lambda, specifically the AWS Lambda service. That's a big part of what this whole course is about, building serverless applications with AWS Lambda. So let's dive in and finally see what the Lambda service is for. What is Lambda? Well, it's a service that allows you to run an arbitrary function on Amazon Web Services. So you can write your own little snippet of code, your own little function in Java or Python or JavaScript running on Node.js. And for this course, since we have to write JavaScript for the website on the client side, to keep it simple, we're going to stick with JavaScript in the Lambda service as well. So it's really a very simple service. There's a trigger that we'll talk about later that causes Lambda to execute your function in the cloud. And it can execute this little function over and over and over again, how many times as you need. Your function does its work, and then it returns a value if that's appropriate, or it might just write data into S3 or DynamoDB or something without returning anything. So often Lambda is sort of the glue that sticks different components together within your larger system for your serverless application. It's actually doing the logic to decide what to write where or what to look up and return back to you. So what makes Lambda serverless? I mean, at the end of the day, it is running on a server somewhere, right? So to answer this question, let's compare Lambda to AWS's Elastic Compute Cloud, or EC2 for short. With EC2, you spin up a virtual server that you can use to do whatever you need it to do. So you might think to yourself, why don't I just spin up an EC2 instance that's sitting there waiting for me to get requests to run my code instead of running my code on the Lambda service? Isn't this the same thing? Well, no, it isn't. So let's take a look at some different things and how they differ between EC2 and Lambda. One is the time to spin up. So on Lambda, you can create a new execution of your function in milliseconds. And if it already has an environment running your function, it can execute almost instantly. Obviously, whatever time your function takes to execute factors in there, but it's going to spin up and run right away. Whereas with EC2, you can provision a server pretty quickly, but then you need to boot up the server's operating system before you can really do any work. So with EC2, it can take minutes to spin up a new instance, but with Lambda, it's always sitting there waiting for you to go right away. Billing increments. So Lambda bills you for just the time it took, rounded up to the next 100 milliseconds. So the cost, if you're out of the free tier, maybe it's just free for you, and for this course it probably is just based on the time and the amount of memory that you use. So you're getting billed for exactly the compute power that you're actually using, rounded up to 100 milliseconds. EC2 bills by the second, and the cost depends on whether the instance was reserved or on demand or spot instances and the type of server that you want. Since your EC2 server is going to be sitting there running all the time until you shut it down, you might end up paying for a lot of computing resources that you're not actually using. Let's talk about configuration. So for Lambda, all you need to do is code up and build and upload your function. And from there, triggers will execute it however it's required. There's really nothing more to do there. But for EC2, you have to set up a whole operating system, and this has two major headaches. First of all, it's not always easy to get a server to boot up and run a service automatically. That's not a trivial thing. You don't want to have to log into the service and start up your service in every boot. Secondly, you have to pay for the operating system boot time. If you have a fast Lambda function that runs in under 100 milliseconds, you pay for 100 milliseconds of time, but you might pay for minutes of time with EC2 to run that same function just once. Now you might get some economy of scale on this over time, but let's talk about scaling units next. So we've talked before about the unit of scaling. Lambda scales seamlessly up to 1,000 concurrent executions. It's all about the workload for scaling, not some arbitrary granularity. As for the limit, it is possible to ask AWS for more than 1,000 concurrent executions, so even that's not a hard limit. Now with EC2, you can only scale by adding more servers. If you can run on the smallest, cheapest instances, that's great. You can just pile them up as you need them, but you're still going to be paying for CPU time that you're not going to use. If a server can run 10 concurrent executions, you can only scale in increments of 10. It's just not as granular in how well you can scale that out, which means you end up wasting money. Finally, let's talk about maintenance. This talks about dealing with patches and kernel upgrades and security fixes. The nice thing about Lambda is it's just a service that runs your code, and AWS worries about the actual server that it's running on for you and keeping that up to date. But with EC2, it's completely on you to manage that operating system yourself. Sometimes you can just restart the instance with an updated image, but that still takes time and has to be done explicitly. It's a bit of a misconception that EC2 manages your servers for you entirely. It's still up to you to keep the operating system itself up to date. So you can see that using the Lambda service doesn't really feel like using a server. It's more like a hosted web service that does whatever you want. And that's the real power that we want out of it for our serverless chat application. It's just a service where we can throw a little chunk of code, a very lightweight piece of functionality, and execute it on demand whenever we need it to, very quickly and very reliably.